started the rate of change, which is 3.11. And I just thought that you would kind of grab onto it because we are, just to make sure it's 3.11. Yeah, related rates. That you are actually doing implicit differentiation. Okay? When you're actually doing the derivatives, except remember when we did x squared plus y squared is equal to 10. Okay, now when we do implicit differentiation, you're not only doing it because you don't have implicit differentiation, you're not just doing it because you don't have anything equal to y. You're also doing it because you're differentiating two variables, more than one variable. Okay, write that down, more than one variable. And you're also doing it because, well, you're doing it because you don't have anything to solve for. There's no y equal. Okay, so, and you're also you're differentiating more than one variable. So that's when you use implicit differentiation. Now, the textbook way of doing this is to take x squared, and since you're taking it in terms of x, so remember we don't have t here. There is no t. So you just do 2x plus 2y dy dx equals 0. Now see, this is the part right here that I changed to y prime, but when you've got t involved, you've got to change everything. That would be dx dt, that would be dy dt, and then that would be 0. So if you're taking this x squared plus y squared is equal to 10, and time is involved, and what can you say about everything? What can you say about all the problems with related rates? Feet per what? Feet per what?
Seconds.
And what is seconds?
The time that's involved.
The time. So all of these questions that you're going to be dealing with are going to be a third variable involved. And that third variable is time. So now I'm going to take this with time, and that's going to be 2x dt dx, or dx dt plus 2y dy dt is equal to 0. Okay, so you need to be aware of that, and I thought in implicit differentiation you would be aware of that, but I maybe did not mention that since we have a third variable, and since we are doing a differentiation more than one variable, more than x, that you would have automatically thought implicit differentiation. So what if I did a is equal to s squared with time? Okay, what would be the derivative of a is equal to s squared with time? Well, that would be d. Well, I'm going to take the derivative d of t of a, d of t of s squared, meaning I'm going to take the derivative of a with respect to t, and I'm going to take the derivative of s squared with respect to t. So what is the derivative of a? One, Hubert. That's right, class. But I've got to keep it in respect. Instead of writing a prime, I'm going to write dA dt is equal to 2s times what? ds dt. And this is your dA dt is equal to 2s times ds dt. So that's where that's where all these dA and ds dt's come from, the implicit differentiation. Did everybody get confused about that? Because if you did, I just showed it to you. The derivative of A in respect to t is 1 dA dt. The derivative of s squared with respect to t is 2s ds dt. And what these are right here, what are these called? Rates of what?
Change.
Rates of change, and they will usually be what? They will be given, or one will be given, and you solve for the other. Okay? So this would be area. Let's say the area changes on a circle 3 meters squared per second. That would be dA over dt. The time changes 5 seconds. That would be every 5 seconds. That would be ds dt. All right, I'm going to let you do this one. And this is just kind of an introductory to these questions. All right, you take the derivative in respect to time of the area is equal to, and take the derivative in respect to time of length times width. All right, you do that. Product rule here, but you got to use the product rule with implicit differentiation in respects to time. So first times the derivative of the second plus the second times the derivative of the first in respect to time. So dA dt is equal to L times 1, the derivative of W is 1, and that would be dW dt, plus W times 1, which is the derivative of L, times dL dt. So your final derivative is dA dt, which is the rate of change of the area, equal to L times the rate of change of the width plus W times the rate of change of the length. So like I said, I just took for granted that coming off of the implicit differentiation, I took for granted that y'all would make that jump, and I think some of y'all didn't because of the questions I was getting. So, and yes, this class did send me questions. So, but I'm not going to say their names because I fear that some of them might get beat up because they're communicating with me. So I'm not going to mention their names. I don't want anybody to get beat up by the weenie patrol, the weaned on a pickle patrol. I'd hate to see Mr. Piella be beat up outside of the library by the weenie patrol.
Come on, Weenie Patrol. I can take it.
That's it. Kind of like the what's that bar that SpongeBob and Patrick get their ice cream at? What's it called? Not Goofy Goober. But
Super Weenie Hut Juniors.
Yeah, Weenie. That's it. Weenie Hut Jr. I'm not a weenie. Yeah, you are.
I'm more of a
All
Weenie
right.
Hut general.
Weenie Patrol. Weaned on a pickle. Supposed to show me your video, you show me your ceilings and your ceiling fans. All right. The legs of an isosceles right triangle increase at 5 meters per second. All right, there is a rate of change right there. So that would be like dl dt right there, dl dt or dx dt, depending on how you write it. I'm going to write it here in just a second. A. At what rate is the area? At what rate is the area changing? Well, there's dA dt right there. At legs equal to 1 meter. And then B, at what rate is the area changing when the hypotenuse is equal to 6 meters? And C, at what rate is the length of the hypotenuse changing? Okay, the first thing you do with these questions is you've got to draw a picture and you've got to find out what you have. So before you even start the problem, you draw a picture. There's an isosceles triangle. Somebody tell me what isosceles means.
It has a right angle.
Yeah, but what's the isosceles mean?
2 equal sides.
2
The
equal sides.
two legs
One
are what?
extra.
Equal. And here's the hypotenuse. So, what's the area of a triangle?
Base times height divided by 2.
So 1/2 base times the height. And we are given the rate of change of what?
The legs.
And they also say for A, X is equal to 1 meter, but we'll get to that in just a minute. So, I need you to give me the derivative in respect to time of this guy right here. give me the derivative in respect to time of this guy right here. So I'm going to do that in orange, so it'll show out a little bit. So d dt, d dt, and then I'll write the formula. A equals 1/2 x squared. So I use my green marker to show that I'm taking the derivative. So that's going to be 1 times dA dt. Now somebody tell me what DATT stands for. What does that stand for? Give me the words. Define what that means.
The rate of change of area over time.
There it is. The rate of change of this area. That's what that means. Is equal to, well, 1/2. I really don't worry about the 1/2. I just pull that out. And 2x. And what's left? D what? Now, it looks like to me you need to simplify and plug and chug. Now do it, because x is equal to what?
2x.
Okay, do it. Plug and chug. See what you get. Simplify and plug and chug. So dA dt, the change in area in respect to time, is equal to, the 2's cancel, leaves you with x times dx dt. So the area in respect to time is equal to x times the rate of change of x. So somebody tell me what we're going to plug in.
1
Times what?
dx over dt.
What is dx dt?
5 meters per second.
Which is 5 meters squared per second. So that means that the area of this triangle, when it starts to, when x is equal to 1, the area of this triangle is 5 meters second, is changing at 5 meters squared per second. Now you've got to picture that. It's growing like this. That triangle is growing. And when x is equal to 1, ding, that area is growing at 5 meters squared per second. All right, do the second part. You'll have to use some Pythagorean theory because you got hypotenuse there. So go ahead and start it. I'll give you a hint. X squared plus x squared is equal to h squared. That's the formula you're going to be dealing with. And you're going to use this right here. You're going to use this right here to figure out for the hypotenuse. So x squared plus x squared is equal to h squared. 2x squared is equal to h squared. And I want it in terms of x because that's what we got to plug into the formula, x. So x squared is equal to h squared divided by 2. And the square root of both sides, x is equal to h over the square root of 2. What is the hypotenuse? According to the question, what is the hypotenuse?
Six meters. It says it's square root.
6, and that's going to go over the square root of 2. So x is equal, for the hypotenuse, 6 square root of 2. So now I pull up my, the difference in the area, the rate of change of the area in respect to time is equal to x times dx dt. And what is x? X is 6 square root of 2 times 5 and I get what, 30 over the square root of 2. And since there's a radical in the denominator and this is an answer, I'm going to multiply by the square root of 2 over the square root of 2, which is 30 square root of 2 over 2, which is 15 square root of 2. So your area of your triangle, so the area of the triangle is changing at, what's 15 times 1.4? 15 times 1, that's 1. And then half of 15 is 7. So that's going to be, y'all give me a second, hold on. 7 and 15 is what, 22? So the area of the triangle is changing at 22 plus or minus some change meters squared per second at the hypotenuse equal to, what was the hypotenuse equal to? 6 meters?
Yep.
So that area at hypotenuse is equal to 6. It's growing. That area is growing at hypotenuse is equal to 6. 22 plus meters squared per second. So think of a balloon or a tire inflating. That's what we're talking about. Now, there's all kinds of derivations of engineering applications. The first thing I come up with is air in a tire or air in a balloon. Okay? And now the third part. The third part says, at what rate is the length of the hypotenuse changing? At what rate is the length of the hypotenuse changing? Well, we said a while ago that x is equal to h over the square root of 2. Or you could say h is equal to x times the square root of 2. However you want to say it. We're going to use this one because we're going to take the derivative of this. In respect to in respect to time. So that would be d8, or I'm going to just write d over dt of h equals d over dt of x times the square root of 2. All right, I want y'all to do that. Take the derivative of h, take the derivative of this, that's a number times x, and then remember you got to have something in place of it because it's implicit differentiation. So this is going to be dh over dt, and this is going to be dx over dt, so don't forget that. Go ahead. Ooh, Mountain Dew and Diet Mountain Dew and toothpaste. Woo, that's nasty. So somebody tell me what you get over here for this one. What do you get on the left side? 1 times what? dh dt?
Yep.
That's the change in the hypotenuse in respect to time. All right, somebody give me the right-hand side. What's the derivative of any number times x?
X.
And what do we put to replace it since we're using implicit differentiation with t?
Dx over dt.
Dx over dt. Don't y'all feel smart? Don't y'all feel like Beautiful Mind? Or don't y'all feel like Good Will Hunting? Oh, I love those two movies. Those two movies. Y'all ever seen those two movies? Oh, yes, not animated. I'm sorry.
Yep.
Maybe one day when they animate them, you can watch them while you're eating your Tide Pods. All right, so dH, the difference in the hypotenuse, is equal to x times dx dt. And somebody tell me what we already have. Oops, I'm sorry. Square root of 2 right here. The derivative of 2x is 2, not the x. Sorry. And what do we have right here? What do we put in for dx dt, y'all?
12 over 2.
No, what's dx dt? Come on. Get into the problem.
dH dt. 5 meters per second.
5 meters per second. So that's going to be square root of 2 times 5. And what does that come out to be? Somebody check me. 7? Around 7? Somebody help me out. 7.1. Somebody take the square root of 2 and multiply it by 5, please.
7.07.
7.07 meters per second. So your hypotenuse is changing at 7 meters per second at, so the rate, let's see, what was the question saying? Oh, yeah, that's the rate is changing. So 7 meters per second. That's 21 feet per second. That's changing pretty what? Pretty fast, Hubert. Yeah, thank you, class. All right, let's do another one. You feel better? You feel like you're getting a better grasp of it? Since I showed you that implicit differentiation?
Mm-hmm.
Okay, nobody's going to say anything. That's fine. It's a great way. It's a great way for a teacher to know what his class is doing, for the class to say absolutely nothing. So thank you. Appreciate it.
I thought you were psychic.
No, that's females. Females are psychic. When you get married, their psychic abilities increase. And yours, guess what yours do when you get married?
It gets smaller.
They get decreased. They decrease. Yep. And the women, they think you can read their mind, and you're like, duh, where's the football game? Where's the beer? And it doesn't work out very well. That's why men should not get married until they're 28 and above. All right, so this is one. I'm going to do an easy one for you. 3, this is like number 5 in your homework. A circle has initial, I don't know if I'm spelling it right or not, radius equal to 50 feet. When the radius starts decreasing, when radius starts decreasing at 2 feet per minute, what is the rate of change of area? Somebody tell me what the rate of change of area is. D what over D what?
dA over dt.
D capital A over dt. So you're going to, okay, of area when radius is equal to 10 feet. So first of all, let's write down what we have and what we know. We know that the initial radius is equal to 50 feet. We know that dr dt is equal to 2 feet per second. And what's the area of a circle? Yes, that's right. Pi r squared, class. Okay, so just entertain me and take the derivative of this guy, and let's see what happens. Go ahead and take the derivative. Now remember, pi is like a number. So this is like 3r squared. So remember that when you're taking the derivative. So go ahead and take the derivative, the implicit differentiation of the area. I'm going to give you a minute. Give you 1 minute. Can't give you any more. Give you 1 minute.
Two pi r.
Nope. You didn't say it right. You got right components, but you didn't say it the way I want you to say it in this unit, in this section. Give me the whole thing, Mr. Piello. In other words, what's on the left side of the equal sign? Okay, your mic. Go ahead, your mic. Fix your mic.
Dr dt.
dA, the area.
Oh.
See, right here.
dA dt.
There you go. dA dt. And what's the derivative of A? 1. Now, if that was 2A, then it would be 2dA dt and then a 2. But since it's just A, it's 1. Is equal to, what'd you say, pi r or 2 pi?
2
What'd
pi
you say,
r.
2 pi r?
Yes, sir.
So I'm going to pull the pi out, and that would leave 2r And then what? D what?
dr dt.
Oh my. What's the only thing left to do?
Evaluate.
Plug and chug. We got R is equal to 10. So pi times 2 times 10. And what's dr over dt?
2 feet per second.
And that comes out to be 40 pi feet squared per second. So this one was just plug and chug. So this means, what does this mean? This means that when your radius is equal to 10 feet, the area of your circle is expanding 120 feet squared per second. 120 square feet per second. 120 square feet is your bedroom. 10 times 12, that's a standard bedroom. So it's expanding the area of your bedroom, or a 10 by 12 bedroom, per what? Second. A rectangle has initial dimensions I don't know how to spell dimensions, y'all check me, of 2 centimeters times 4 centimeters. Is that how you spell dimensions?
It's with an S instead of a T.
That's what I thought. Okay.
DIMENSIONS.
Yeah, the S, I always want to put a T there, like dementia. Yeah. Okay. All sides begin to increase at 1 centimeter per second. At what rate is area changing, increasing after 20 seconds? Okay, so I'm going to take my handy dandy highlighter and somebody tell me what we're looking for.
Rate of change
Of what?
of the area.
So we're looking again for dA dt. So what do we know? We know that the length is equal to 4 plus t centimeters, because it says right here, all sides begin to increase at 1 centimeter per second. And 1 over 1 is 1, so that's t centimeters. And the base is equal to 2 plus what? T centimeters. So technically, there we go. Put it in parentheses. So tell me the area of this rectangle. Go ahead. You got two binomials right there, so you got to do what? Length times width?
Priority 1 message coming in on secured channel.
I got a Ring camera put on my mother's house, and every time the cat walks in front of it, it goes off on my phone.
Is that what that priority 1 message means?
Yeah, no, that's me having a reminder that I've got to pick up my mother at 15 till 2.
Oh, don't we get out early today?
No,
Or is
y'all
that-
don't get out early. In fact, y'all stay a little bit later because I got to get all these questions in for the second class. The second class don't have class, but I think there's another day this week that either both of y'all don't have class or one of y'all don't have class. I got to look at my calendar. Let me look at it right quick. Which I'll just give y'all another video. I think it's the other class. But I might skip that. And I think y'all are good this week. Mr. Lowry, were you in class yesterday? Because I couldn't remember hearing from you yesterday. Were you in class?
I was in the car, but I joined late. I joined at like 12:45 yesterday.
Oh, I just knew I didn't hear you.
No, is that unusual?
Yeah, I can hear your voice, when you're correcting me when I make mistakes.
Yeah, I gotta be the one. I was gonna let someone else correct your little dimensions error right there. I was about to get you on the T for like right there, but I let somebody else do that.
Oh, okay. Well, I appreciate it. Listen, as long as you understand what the concepts are, I'm sorry about my grammatical and.
No, I'll be the one that.
I'm terrible. I used to be good at spelling. I was like the 5th grade spelling champ at Marinus. But after that, after junior high, pretty much sucked.
Mhm.
All right. So A is equal to length times what? Width. Or base times height. And that's going to be, you know what to do, the FOIL method. And that's going to be what? T squared plus 6t plus 8?
That's right.
Okay, now do your thing. Let's take the derivative. Let's see, that's going to be dA dt times 1 is equal to 2t. And since we are taking derivative of t in respect to t, we don't have to worry about, it's like taking an implicit differentiation. If you're taking the derivative of t, then you're okay. So plus 6, and that's it. So here's your formula. And all you need to do now is plug and chug. What are you going to plug in? What are you going to plug in? I'm telling you right here.
20.
20. So therefore, 20 times 2 plus 6. Hell, what is that? 46? 46 centimeters squared per second. So this rectangle, since this is increasing, so what you could do is think of a rectangle Think of it increasing 1 meter per second, like that. And at 20 seconds, the area is changing at 46 square centimeters per second. Now, 46 squared centimeters is like 23 by, I don't know, 23 by 2 of your fingernails. Width of your fingernails, that's a centimeter. So 23 of those by 2 up. So you're talking about an area about like that. We feeling better? Yeah, Hubert. No, Hubert. We eating Tide Pods, Hubert. 311. Have y'all seen that fella that went up against Mayweather? Now he says he can beat Mike Tyson. That boy better stay off the Tide Pods. He's going to end up in the hospital. Because Mayweather, you know, when he hits you, that's a brick. When Mike Tyson hits you, that's like a freaking 15-pound bowling ball. Have y'all seen that on TV?
I've seen
And you
parts
know,
of
an
it.
exhibition, unless the fighter don't like you, they're not going to go that tough on you. And Floyd Mayweather, or whatever his name is, hey, he wasn't that tough on what's his name? What's that guy's name anyway?
Logan Paul.
Yeah. Somebody better talk to him because Mike Tyson hurts people. Y'all see what he did to that dadgum, what do you call it? What do you call the octagon? What's it called? He floored that guy. Oh, nobody's gonna say anything, so I'll just shut up. Area of a circle. Y'all don't condone violence. I forgot about that. So the generation now, y'all all butterflies and rainbows. So y'all just eat Tide Pods and y'all don't condone violence. That's for us cavemen, Generation X people. Increase at a rate of 3 centimeters squared per second. Somebody tell me what they just gave us. What did they just give us right here?
dA dt.
dA dt is equal to 3 centimeters squared per second. Good job. A, how fast is the radius changing at R is equal to 1 centimeter? B, how fast is the radius changing when the circumference is equal to 1 centimeter? Now, what do you know? You already know this. And you know that area of a circle is equal to pi r squared. So I would start with the derivative of the area of a circle equals pi r squared. I would start with that. So go ahead and get started. So what is the area? What is the derivative? That's going to be dA dt times 1 is equal to, that pi comes out. And what is the derivative of r squared?
2r.
2r d what? dr dt?
Yeah.
I'd go ahead and plug in that 3 right here. And that'll give me 3 times 1 is equal to pi 2r dr dt. Wait a minute. R is equal to what?
To 1 centimeter.
So you can plug that in right here, and that's all you gotta do is simplify it. Plug in 1 right here. And now just simplify it. 3 is equal to pi times 2 dr dt. So divide by 2 pi. Divide by 2 pi. Dr dt is equal to 3 over 2 pi, which is what, about a half? Because 2 times 3 is 6. So it'd be 3 over 6, which is 1/2. Somebody crank that out and give me the decimal 2 places, please. Just for giggles. I said 1/2, 0.5. What does it come out to be?
Why are you dividing by 2 pi?
To get rid of it right here. I'm solving for dr dt. How do you get rid of multiplying by 2 pi?
Well, you divide it.
There you go. Dang old algebra, dang old pre-algebra, dang old. Somebody get a decimal for me?
I think so.
What'd you get?
I got 0.95. I'm not sure if that's right though.
Well, it could be, but I thought 2 times 3, I thought it'd be around 0.5 or 0.46. That's all right, I'll do it.
I got 0.48.
0.48?
Yes, sir.
Okay, so do the second part. Now you might have to think a little bit for the second part, but I will tell you that you're going to still use A is equal to pi r squared. So, what do we know? We know that the circumference is equal to 1 centimeter. We know the circumference, and we know that circumference is equal to 2 pi r. Well, since we're using area is equal to pi r squared, what do we need to change circumference into?
Just square it.
We need to change the circumference into what? Radius. So divide by 2 pi. Divide by 2 pi. So r is equal to c over 2 pi. And we're going to plug that in right there. And that's going to give us a is equal to pi times c over 2 pi squared. A is equal to pi times c squared over 2 squared pi squared. And that's going to give us A is equal to, well, that'll cancel with one of those pi's and leave one pi. So that's going to be C squared over 4 what?
Four pi.
And that right there is your formula that you're going to take the square root of, I meant the derivative of. Take derivative. Go to it. All right, so what is the derivative of A? dA dt times 1 is equal to 1 over 4 pi times 2c times what?
DC over GT.
You are a winner. Now we know the circumference is equal to 1. And we don't have dc dt. We got dc dt from the beginning. Hold on. 2 pi r yeah, 2 pi r 2c. Okay, go ahead and simplify that. Now, we know that dA dt is equal to 3, right? Because that's changing the area increases. That's 3 is equal to 1 over 4 pi times 2c dc dt. And crunch all this down, and that's going to be 2 over 4 pi. So 3 is equal to 2 over 4 pi c dc dt. And to get rid of multiplying by 2 over 4 pi, we got to multiply by 4 pi over 2. Multiply by 4 pi over 2. I get 12 pi over 2 is equal to c dc dt. and that's 6 pi. So 6 pi is equal to C dc dt. And C is equal to 1. So 6 pi is equal to 1 times dc dt. So dc dt is equal to 6 pi. Let me read the question. The question said, how fast is the radius changing? Well, we've got the change in circumference. So we've got to change this into radius. This right here this says the change in circumference over the change in time. So we've got to change this. So we're going to take the derivative of 2 pi r. So 6 pi is equal to the derivative of 2 pi r, because that's the derivative of the circumference. I mean, the derivative of the circumference, you could write it like this. You could put circumference is equal to 2 pi r right here, and then put that right there. Now you could do that if you wanted to. And that's going to be 6 pi is equal, that 2 pi comes out and leaves r. What is the derivative of r? 1 times dr dt, and that's what we want right there. And divide by 2 pi, and your answer is 3. Now the question asked, how fast is the radius changing? It is changing, the radius is changing at 3 centimeters per second at circumference is equal to 1 centimeter. I'm just showing you that last part because some of you may wonder why I did that. Well, the question says, at how fast is the radius changing? Well, at this point right here, we don't have the radius. We have the change in circumference. The change in circumference due to time. So we got to change that c to 2 pi r. So we got to take the derivative of 2 pi r because the circumference doesn't help us. So 6 pi is equal to the derivative of circumference, which is 2 pi r. And that comes out to be dr dt. And that's what we're wanting, the change in the radius. So the change in the radius is 3 centimeters per second when the circumference is 1 centimeter. Now, I don't mean any harm, but I think some of y'all should be feeling pretty good with these homework questions because I've gone through like 4 or 5 of them. I'm going to start you on this last one, because time's about out and then some of y'all go into heart attack mode. A fisherman hooks a fish. A fisherman hooks a fish and reels it in at 4 inches per second. So I'm going to say that's going to be dx dt. Assume the tip of the rod is directly above him at 12 feet above him. And the fish is pulled horizontally across the top of the lake or whatever. Find the horizontal speed. Find the horizontal speed of the fish (25 feet) from the fisherman. Okay? But first of all, we got to draw a picture. So the pole is 12 feet. The tip is 12 feet from the ground or from the lake elevation or whatever. So that means 144 inches. Why did I change it into inches? Why did I change
It's easier
the
to
height
convert the
to
feet.
inches? Because the rate of change in respect to x is in what? Inches. Now you could have changed that to 4 over 12, which would be 0.25. You could have changed that 0.25 feet per second. You could have done that. But I'm just changing it here. And this is x. And this is h. So h squared is equal to x squared plus 144 squared. And h squared is equal to x squared plus, I got 207.36. Y'all check me, please. And that right there, I want you to take the derivative of, because that is the hypotenuse. Right there, that's how much the hypotenuse is changing, which is his dang old line. This is his line. That's the fishing line. So we find that distance and we find this distance. 25 feet. And of h squared plus x equals h squared is equal to x squared plus 207.36. Now I'll do this for you. I'll take the derivative of the number right here. Okay, I'll do that for you. The derivative of 20,736 is 0. There. I did that for you. But this is going to be, oh, this is going to be 2h. This is going to be 2h dh dt is equal to 2x dx dt plus 0. Well, we can simplify this because this basically says 2h dh dt equals 2x dx dt. The 2's cancel. So you're left with h dh dt is equal to x dh or dx dt. Now, your Pythagorean theorem, let's go back to the Pythagorean theorem. Your Pythagorean theorem says h squared is equal to 144 squared plus, let's see, 25 feet. Somebody multiply 25 feet by 12. What do you get?
300.
300 squared. And somebody crank this out. I got h is equal to 332.77. See if y'all get the same thing. And now we just plug and chug and solve for dx dt. So dx dt right here, divide by x. So dx dt is equal to h dh dt over x, and that's going to be 332.77 divided by 300 multiplied by 4, because 4 inches per second. Crank that out, and I got 4.44 inches per second. Somebody check me. See what you get.
That's right.
I've got one more, and those of you that want to stay can stay. Let me get the roll right quick. And anybody who wants to leave, they can after I take the roll, and they can watch the video later. So I'm just going to turn off the screen presentation right quick and look at the roll. Y'all give me a second. I haven't logged on to My Labs Plus. I meant to TCTC at all. That's the only way that I can do it and not log me out. So I have to log in, so just hold on. Faculty attendance tracker, this is 140.01. And the only people I'm looking for now is Mr. Bridges. I don't see him. Hull is here. Martinez. Let me look for Martinez. Yep.
I'm here.
I got you. Okay, now anybody who wants to leave can leave. I'm going to keep on going. I got one last problem. And the reason I would suggest you listening to this one is because you're going to see this one next semester. You got a conical tank. Let me present screen again. You got a conical tank. And that conical tank is conical. Hold on. I'm trying to get everything back to normal. You got a conical tank. It is 12 feet high and a radius of 6 foot, and it's being drained. That's dV, dt. It's being drained volume at 2 feet cubed per second. All right, so they give you a paragraph, and it basically tells you this. And they want to know what is the rate of change of the water at a depth of 3 feet. Okay, so the first thing you're going to do is set up a similar triangle, because you've got a tank that looks like this. It's 12 foot high and 6 foot radius. And here's your radius, and here's the height. So 12 is to 6, as H is to R. Cross multiply, you get 12R is equal to 6H. We always get for R because that's what's changing. So R is equal to H over 2. All right, so that's your first step. When you're dealing with a conical tank, that's your first step. Okay, the second step, volume. What's the volume of a conical tank? Well, if you don't know it, it's V of a conical tank and you will learn it in second calc, 1/3 pi r squared h. So I want you to take the derivative. You might want to simplify it a little bit because you got r, that's h over 2. So you might want to plug that in because everything in terms of r. So that's going to be V is equal to 1/3 pi. Didn't we say it was h over 2? And now simplify that. 1/3 pi of h cubed over 2, over 4, sorry. And that is pi times h cubed over 12. So now all you got to do is take the derivative of that. So I'm going to take the derivative. That's going to be dV over dt is equal to pi over 12 can come out. And I'm going to take the derivative of h cubed. So dV over dt is equal to pi over 12 times what? 3h squared dv dt is equal to pi h squared over 4 d h dt. And somebody tell me what we have from the beginning of the question.
We have
Well,
dr.
dv dt is 2 feet per second, or 2 feet cubed per second from the beginning of the problem right here. dv dt is 2. So that's going to go right here. And we want to know the height at 3. H is equal to 3. So plug in what?
Plug and chug.
Yep. And you just do all of that. I'm going to put 3 dots right here. And I got, where's my answer? I got 8 over 9 pi is equal to dH over dt. And I don't know what 8 over 27 is, but 8 over 24 is what, 1/3? So somebody do that on the calculator. It's going to be around 0.3, 0.31 or 0.3. Somebody check it for me. What do you come out with? What's 8 divided by 9 pi? Might be a little bit because I did 1 over 24. You're doing 1 over 27. So it's going to be a little bit off of 0.3. What is it?
2.79.
Huh?
2.79.
Times 10 to the what?
That's all I got.
8 divided by 27 is not going to be 2 point something. It's going to be point something. So 8 divided by 9 pi. That's not right. 8 divided by 27 is not 8 divided by 27. There's the answer. I don't know. Oh, I know why. Because the calculator can't do this. Let me do it differently. 8 divided by parentheses 9 pi. There's a prime example of the calculator cannot do what you can do, and that's think. There
I
we
got
go.
0.28. Like
It's
that.
0.29, 0.28, somewhere in there. I said 0.3 and I was doing it in my head. So I guess I was close enough. All right. Now let me ask you a question. You feel a little bit better about 3.11 now?
A little bit.
Since I actually did y'all's homework for you, because I think I did like 5 out of 7 problems. All right. See y'all.
See ya.